Hello guys, this is Rakesh from Bodhee Prep, and in this video we'll be taking another very interesting topic from algebra. We'll be taking the basics of that thing, and that topic is inequality. It's a very interesting topic and very important as well, right? So before we get into the mathematics part of inequality, let us try to understand what is the concept behind having a topic like inequalities within the mathematics, right? So I'm writing a very simple thing here that there is one number 5 and there is another number 4, right? If I make equal to sign between these two, all of you would agree that I have made a mistake, right? 5 is not equal to 4, correct? So I should correct it. This is not correct. If I want to correct it, I should be correcting that 5 and 4 is not equal, right? This is the correct statement to make, that 5 and 4 is not equal. Now, to understand inequality, what we do is that we want to get into a depth of this. Of course, 5 is not equal to 4. I want to add something more about it. I can say that 5 is not equal to 4. Rather, 5 is greater than 4, right? So I'm introducing a comparison, this phrase greater than. This is a comparison, right? Do we have anything in mathematics which represent greater than? Yes, we do have. So obviously it should have some sign, right? Because this sign is equal to sign, right? This is a sign of equal to. So is there a sign of greater than? Of course. And that sign is this. If something is written here and a sign is between this sign is between this, and something else is written here, it simply says that this portion is greater than this portion, or this part, this term is greater than this particular term. So more appropriate way to write a sign between 5 and 4 is this one, that 5 is greater than 4. If it is greater than, definitely 5 is not equal to 4 is automatically considered, right? Now, if there is a sign for greater than, then definitely there must be a sign for less than, right? For example, if I want to introduce a mathematical sign between 3 and 4, of course, 3 is not equal to 4. So we can say that 3 is less than 4. Now, less than 4, this phrase in mathematics, we represent it something like this. If I introduce this symbol like this, then we can say that the term 3 or the number 3 is less than 4, right? So this is the world of inequality, wherein rather than using the equal to sign, we introduce the inequality signs, which are either greater to or less than, right? Of course, there are certain more variation about it, but these are the primarily two signs which we use in inequalities. I hope you have understood the basic understanding about the sign and what's the topic for this particular video, right? Okay. Now, since we are interested more about algebraic inequality, so what we can do is that we can take one example to understand that is there any uh, real life this utility of this inequality or not, right? So, for example, I have 200 rupees at my pocket, right? I went to the market and I want to buy some number of pens. I want to buy some pen, correct? And all pen will be of, they will be alike, and their prices, each pen prices will be also same. Now, if each pen is costing rupees 30, what is the number of pen I can buy, right? Or I could have bought. For example, I want that, make a guess that what number of pen I bought some pen. What is the number of pen I could have bought? Of course, there will be several possibilities. Mathematically, if I want to find, then what I can say is that what is not known, the known unknown thing is what? The number of pen. So let me assume that number of pen bought is equal to X. So what is the total amount I'll be investing to buy those X number of pen? Of course, it would be X into 30, right? 30 is the price for each pen and X is the number of pens. So this will be the total cost. I have total 200 rupees only. I have to just invest 200 rupees only. I can't invest more than that. Clearly, I can say that the total amount I would be spending, it will never exceed 200, right? Let me repeat. The total number of, or the total amount I'm spending to buy those X number of pen, it will never exceed 200. It can be equal to 200, but it will never exceed 200. So I can say that this should be less than 200, or this could be equal to 200 as well. These are the only two possibilities, right? Now, it is quite evident that this value x has to be a positive integer. It has to be a positive integer. It can't be in fraction, because I can't go 7.5 pen. It's not possible. Either I'll be buying 7 pen or 8 pen or 6 pen or 0 pen or 1 pen, something like this, right? It has to be a positive integer. So if I just want to solve this, right, without involving the method of solving inequality, I just want to make guess. Then what I can say that, let me substitute the values of x and try to figure out that what is the maximum possibilities of number of pen I could have bought. Say if I'm buying 0 number of pen, is it satisfying this inequality, this condition? Yes, it is satisfying. 0 into 30 is 0, which is less than 200. So of course, I'm not buying anything, any pen, then it's done. But as I said that I have bought some pen, so I'm just ignoring this particular possibility. For x equal to 1, I would be spending 30 rupees. Is it allowing my pocket? Yes, I have 200 rupees, so I can buy one pen by spending rupees 30. So this is satisfying this equation. That means this is a solution or part of the solution, I would say. Buying one pen is allowed. Can I buy two pen? Yes. 2 into 30 would be 60. Again, 60 is less than 200. Can I buy 3 pen? Yes. The total amount spent would be 90. Can I buy 4 pen? Yes. The total amount would be 30 into 4, which is 120. Can I buy 5 pen? 5 into 30 is how much? 150 is allowing me. Can I buy 6 pen? Yes, it is also allowing me. The total amount would be 180. But can I buy 7 pen? No. To buy 7 pen, each worth rupees 30, I have to spend 210 rupees. But my maximum limit is what? Rupees 200. So of course, I can't buy 7 pen. At max, I can buy 6 pen, right? So the answer for my question would be, my question was how many pen I bought or I could have bought, right? I bought some pen, that is understood. But how many pen I could have bought? Now here it would be possibilities, but the possibility will have some range, and that range would be either I would have bought only one pen, or 2 pen, or 3 pen, or 4 pen, or 5 pen, or at max 6 pen. So this is the solution of my question. Clearly, I cannot buy 7 pen with rupees 200. The reason being 210 is exceeding 200. Till x equal to, from x equal to 1 to x equal to 6, this will always be less than this, right? So I hope you are getting it. This is a very, very rudimentary example. I just introducing it in this way because I want you to understand that mathematically, if we represent something, then how do we interpret it, right? As I said that I could have spent the entire 200 rupees also to buy the pen, but that is not possible. The reason being, this 200 is not a multiple of 30, or we can say that 30 is not a factor of 200, or I can say that 200 doesn't appear in a multiplication table of 30. Had it been 210, then I could have bought the 7th pen as well by spending the entire amount of 200, right? So if I want to solve that, what is the uh, better way of solving it? What I can do is that I can just take this and I can say that 30 into x should be less than or equal to 200. So what I have done is that I have combined both the possibilities by introducing a new kind of sign, less than or equal to, right? So something can be either less than or equal to. It is not exceeding that. It can be equal to it, but or less than that is also acceptable, but not exceeding that, sorry, exceeding that is not possible. That's the I would say the condition of this particular problem. So this condition is known as less than or equal to, right? So I hope you are understanding it. Now, if I make another sign like this, I hope you would have realized it that this symbol will represent greater than or equal to. So both possibility will be under the consideration, or both possibility will be part of the solution, right? Now, I want the value of x. So what should I do? I should get rid of 30. So the same thing which we used to do in the linear equation of one variable, we'll be doing it here. How do I get rid of 30? 30 is multiplied here, so I should be dividing both the side by 30. So if I divide both the side by 30, what do I get? I'll be getting, this will get cancelled out. Here, x will be less than equal to 6.67, approximately 6.67. X being an integer, positive integer, the value has to be 6. It cannot exceed 7. So we can say that the value of x has to be less than or equal to 6, but not be exceeding it for this particular question itself, right? Otherwise, this is the only solution. But since it is talking about pen has to be integral value, that too a positive integral value, then we can say that the maximum value which we can buy, or the maximum number of pen which I can buy is 6. I could have asked this question also. If I have 200 rupees, each pen is costing rupees 30. What is the maximum pen I can buy? Again, we would be proceeding the same way because I want the maximum value which x can take under this mathematical condition, right? So I have introduced in fact, I have introduced 4 different symbols for the inequality. One is greater than, the other one is less than, then combination of greater than or less than with equal to sign, greater than equal to or less than equal to. And I hope you have understood that how these two are different and how these two are different. This is a combination of two possibilities together. This is again a combination of two possibilities together. They are as they have been defined, like the first one is greater than and the second one is less than, right? Sorry. So these are the symbols. Now, how do we use these symbols in the framing of the equation? That is the one thing which we have to understand. And second thing is that while solving an equation, is there a possibility that the symbol can change? Is there a possibility that the symbol can change? So let us take the second one first, then we'll be coming to the framing of the equation by reading any word problem. Is there any possibility that the equation will change if we want to manipulate the equation? So let's take an example. Say, if I have number 3 and number 2, obviously I want to introduce a mathematical sign between it. So it would be that 3 is greater than 2. Now, if I multiply both this, or say I'm adding 5 both the sides. So this will become 3 plus 5 and this will become 2 plus 5. Right? This is LHS and this is RHS. So this is an inequality wherein LHS has to be greater than RHS always. Now this value would be what? 8 and this value would be 7. Again, adding the same number both the sides, will there be a change in the sign? Of course not. Will be no change in the sign. That means if there is an inequality given, and if I'm adding the same number, the most important thing that if I'm adding the same number both the sides, both on the LHS and RHS, then the sign, the original sign will not change. If it was greater than, it will remain greater than. If it is less than, it will remain less than. Will there be any change if I subtract? Say, if I subtract 2 from both LHS and RHS in this, then it would be what? 3 minus 2, and here it would be 2 minus 2. Here it would be 1, and here it would be 0. Again, we know that 1 is greater than 0. Again, there is no change. That means either addition or subtraction from the same number or by the same number on both the sides will not change the original sign. That's for sure, right? Addition is done, subtraction is also done. Will there be any issue if I multiply? Let's see. 3, 2. This is the original sign. If I multiply both the sides by 4, this will become 12, this will become 8. Again, the sign will not change, right? The sign will not change. Let's try with some other numbers. If I multiply both the sides by 1 by 2, right? Let's take fraction also. So this will become what? 3 by 2. This will become what? 2 by 2, that is 1. Again, 3 by 2 is nothing but what? 1.5. Again, the sign is not changed. Good enough. If I multiply both the sides by minus 2, let's take negative value. Then this will become what? Minus 6. Minus 2 multiplied by 3 will give me minus 6. Minus 2 multiplied by 2 will give me minus 4. Now there is a change. This sign will reverse. Why so? Because in a number line, if this is 0, this is 1, this is 2, this is 3, so and so forth, Here it is -1, here it is -2. We know that -1 is greater than -2. -2 is greater than -3. -3 is greater than -4. And -4 is greater than -5. -5 is greater than -6. So we can say that this number is greater than this. The sign, the original sign has changed. Earlier it was greater than, now it has become less than. That means multiplying by negative value for the positive value, irrespective of what they are, whether they are integer, non-integer, rational, irrational, it doesn't matter. If the number is positive, if I'm multiplying both the side by positive number, then there will be no change in the sign. But if I'm multiplying both the side by any negative number, then there will be change in sign. So we'll just replace the sign from greater than to less than, or if it is less than, then we'll change it to greater. Fair enough, right? What about the division? Let's see. I'm taking another example, say 10 and 8. Correct? I'm dividing both the side by 2. So here I'll be getting 5, here I'll be getting 4. Again, there is no change. I'm dividing both the side by 1 by 2. So this will become 20 because 10 divided by 1 by 2 means what? 10 divided by 1 by 2 means what? 10 is multiplied by 1 over 1 by 2. This 1 over 1 by 2 actually makes it 2 over 1. So that will make it 20. Similarly, here it will become 16. Again, there is no change in sign. So if the number is positive and we are dividing by the same number both the sides, the sign will not change. But what about the negative value? If I divide both the sides by -2, this will become -20 and this will become -16. Again, we can see that in this number line, -16 will be somewhere here and -20 will be somewhere here. So -16 will be greater than -20. So the sign will change. So the sign is changing for the negative value, if you can see, right? Only in the case whether if we are multiplying or dividing. That is not the case with the addition or subtraction. Correct? Next is, if I have say 5 and 4, this is the sign given. There is one more way wherein the sign changes, and that is if I take the reciprocal, right? Let me repeat. If I take the reciprocal in the sense, what is the reciprocal of 5? It is 1 over 5. What is the reciprocal of 4? It is 1 over 4. Now 5 is greater than 4 for sure, but 1 by 5 in decimal term is 0.2. And 1 by 4 in decimal terms is 0.25. We can write it as 0.20 also. Clearly, we can see that 0.25 is now becoming greater. Now, this is represented by 1 by 4, so this will be greater. So, sign is changing if I take the reciprocal, right? So, it is easy to remember that when the sign changes, right? Other than those conditions, in all other cases, there will be no change in sign. Just remember that only in two cases the sign changes. One is whether if we are multiplying or dividing both the sides by negative value or negative number, then the sign changes. Second, if I take the reciprocal both the sides. Just remember these two rules. Apart from these two, there is no other way wherein the sign changes, right? You can take square root, you can take cube root, it will not make any change unless you do the reciprocal or multiply or divide by both the sides by negative value. Then only the sign changes, otherwise the sign will remain as it is, right? Okay. So we have understood the sign. We have understood that when there is a possibility, while manipulating, is there a possibility of change in sign? Yes, there is a possibility, and those two possibilities are in front of the screen: multiplication and division by negative values, or taking the reciprocal. Right? Okay. Let's move. So, what kind of question appear in algebra related to inequality? Of course, if it's algebra, it will have variables, right? So let us move to a very elementary kind of question. So what we can do is that let us solve for x. 5x minus 3 is less than 3x minus 1. When the question says solve, so definitely we have to find the solution for x or the number of possibilities for x which will satisfy this equation wherein the LHS is less than RHS. So what we can do is that we have to take the variable on the LHS and everything else on the RHS. I want to get rid of 3x from here, right? So what I can do is that I want to subtract 3x both the sides so that this will cancel each other, correct? On subtraction, the sign will not change, right? Further, I want that this minus 3 should get sorry, this minus 3, I should get rid of from the LHS. So what I can do is that I can add plus 3 both the sides so that this minus 3 will get cancelled with the plus 3. On addition of same number and on subtraction of the same number, the sign will not change. Here we can see that this will get cancelled out. This will get cancelled out. So what I'm getting 5x minus 3x like term. So there I'll be getting 2 of x. Prime will remain as it is. And here I'm getting minus 1 plus 3 is 2. So the value of x. Now dividing both the side by 2 is a positive value, right? We are dividing both the side by positive value. So again, the sign will not change. Rather, I'll be getting x is less than equal to 1. Fair enough, right? So what is x less than 1 signify? X less than 1 has many possibilities. In a number line, if I want to represent this is 0, this is 1, this is 2, this is 3, etc. And there will be a lot of other numbers between this. All are real numbers. There are a lot of other numbers under this, right? And there will be many numbers between these. Infinite many number between two integers. We have already done that, right? I have used the term real number. So I'll be just discussing what is real number for 2 minutes after I have given the graphical representation of this solution. Okay. Now, x less than 1 simply means that anything and everything which is in this particular range is my part of solution. So this signifies infinite many numbers. The only condition is that that number should never exceed 1, neither it can be equal to 1. So x is equal to 0.99999 infinitely is also a part of solution, but x is equal to 1 is not a part of it. Anything else, for example, x equal to 0 is a solution, x equal to minus 1 is also a solution, x equal to minus 1 by 2 is a solution, x equal to minus 3 by 2 is a solution. Many things, x equal to till minus infinity, it's a solution. X less than 1 signifies all these numbers, right? There is another way of representing this. X less than 1. So we can say that till minus infinity, it is solution. So the way I can represent this is writing those boundaries within a bracket. Writing those boundaries within the bracket. Here I'll be writing 1 and here I'll be writing minus infinity and comma between. So this is actually a representation of any number which lies between minus infinity and 1, excluding minus infinity and 1, because infinity we can't catch. So every time the infinity, we can never say that x is equal to minus infinity, right? It tends to infinity. That's the term which we use. Fair enough, right? So we have understood that this signifies graphically this. We can also write it like this. Good. Now, if the question is, suppose the question was like this, less than or equal to, you would have retained this, you would have retained this, you would have retained this. Now, x is equal to, the solution is x would be less than or equal to 1. So now I can say that not only this as is a part of solution, x is equal to 1 is also part of the solution. So x can be equal to 1 or less than 1, but cannot exceed 1. In that case, the representation of this in such format would slightly differ. That is, it would be minus infinity till 1, but 1 would be included. So we are using it close bracket, right? This curved kind of bracket is called open bracket. So here the open bracket, here both the side it was open. So obviously anything between these two are the solution, but not the extreme values. Here 1 is also the part of the solution and everything between these two is also the part of the solution. So open bracket and closed bracket has to be understood clearly, right? This is not very difficult to understand. For example, if I say that x is greater than or equal to 2. So 2 is also the part of solution and anything greater than 2 is also a part of solution. So here on a number line, this will represent if this is 0, this is 1, this is 2. So anything and everything greater than 2, including 2 is a part of solution. It will go till infinity. So how do I represent this like this, it would be including 2. So I'll be taking the close bracket till infinity and I'll keep open bracket. For infinity and minus infinity, we will never use close bracket. It will always be open bracket, right? So anything like this is not allowed in mathematics. If there is an infinity or minus infinity, it should always be having the open bracket, cannot have the closed bracket. For finite value, it has to be the closed bracket. Fair enough, right? So can we have both the way closed bracket? Yes, we can have. For example, I say that x is either less than equal to 2 or x is greater than equal to 0. So on a number line, I want to signify both these things. X greater than equal to 2. So if this is 0, this is 1, this is 2. Anything and everything, including 2, is part of the solution. Anything and everything which is greater than 0 is also part of the solution. Right? This is not or, rather it is and. Now, I want to find the values of x which satisfy both these conditions. Right? X is equal to 0. Is it satisfying this condition? No. Is it satisfying this condition? Yes. X is equal to 1. Is it satisfying this condition? Sorry, this condition? No. Oh, sorry, this condition is satisfying, but this condition it is sorry, I'm sorry. X is equal to 3. Is it satisfying this? Yes. But is it satisfying this? No. So the first case it is not satisfying, the second case it is satisfying. This is the first case, this is the second case. X is equal to, say, can I take negative value? Let's see. Can I take x equal to -1? Is it satisfying this? Yes. X has to be less than 2. -1 is less than 2. So it is satisfying this. But x has to be greater than 0 also. It is so it is not satisfying this. But if I take the value of x to be 1, it is satisfying both. We have to choose a solution which satisfies both the conditions, right? Condition 1 as well as condition 2. Graphically, you will see that the solution for the first portion is this. The solution for the second portion is this, right? I have made a mistake, guys. I'm very, very sorry. I have made a mistake. X less than equal to 2 is this one. It has to be less than 2, right? Please rectify this. X less than 2 is this. And x greater than 0 is this. I want a common solution. So if I want a common solution, graphically, I can see that the common solution lies between 0 and 2. Because these are the numbers which is lying on both the solution, right? So whenever we have more than 2 conditions imposed on a single variable, then what we have to do for a solution, we have to find the common solution. So the common solution is between these two. So we can clearly say that every number from 0 to 2, including both. Why we are including? Because there is a equal to sign also. It's a part of solution. So how do I write? It would be 0, 2, both close bracket. Correct? If the question would have been like this, then the solution would be from 0 to 2, excluding both 0 and 2 as a number or as a solution. So I hope now you have understood that what is the meaning of common solution and how do we distinguish between open bracket and close bracket, right? What is the best way of representation? Yeah, either you can do this way or you can do this way. These are also the normally the solutions are represented this way. That's the reason I have given this much of time, right? In fact, I made a mistake for greater than 2. So please ignore that thing and you can just rectify the concept by considering this as the part of the solution for this. Fair enough, right? Okay. So let's move to the questions like how do we apply these concepts, because the concept is not a difficult one to understand. The difficult part is that when we have been asked to apply the concept for the question, then uh, how do we apply this concept and how do we manipulate, or what kind of manipulation is allowed, that need to be understood, right? So I'm taking a few more examples. In fact, I have written one more example here. 4x plus 3 is less than 6x plus of 7. 4x plus 3 is less than 6x plus 7. I want to find the solution, correct? Now, 4x and 6x. So I want that x should be on the either LHS or RHS. 6x is greater than 4x, so I want that it should be on the RHS, right? So I am deducting 4x from both these sides. So this will reduce to 3. So these two will get cancelled. 6x minus 4x will be 2 of x plus of 7. I want this 7 to go to the LHS. So I should subtract 7 from both the sides. So this will get cancelled. So I'll be getting minus 4 is greater than 2 of x. Let us divide both the side by 2. So I'll be getting minus 2 is less than x. I can also write this as x is greater than minus 2. If minus 2 is less than x, that simply means that x is greater than minus 2. So what I can do is that I can, if something is written here, if I want to make this portion to LHS and this portion to RHS, then I should also change the sign. Okay. So x greater than minus 2 is the part of solution. Graphically in number line, how do I represent? If this is 0, this is 1, this is minus 1, and this is minus 2. So x has to be greater than minus 2. Can I say this portion should be the part of the solution, excluding minus 2, but anything else? That means 0 is a solution, minus 1 is a solution, 1 is a solution, but minus 3 is not a solution because minus 3 is less than of minus 2, right? So all these numbers will be a part of solution, and every number in this number 9 is called real number, right? So let us give 5 minutes for real number, because we have done whatever in number system we have done, we have understood real number, except in one case where I said that this number or such kind of numbers are called imaginary number. Other than that, whatever we have learned in the number system is a real number. So what is real number? Real number is any number which can be represented on a number line. So can I say all integers, whether they are positive, non-negative or negative, would be called real number, right? So all integers are real number. All fractions are also this real number. 1 by 2, 2 by 3, minus 1 by 2, minus 1 by 3, whatever. They will also lie on this number line. So they are also real number. All rational numbers, any number in the form of p by q will lie on this number line. For example, if I want to find what is 5 by 4, right? So 5 by 4 is nothing but somewhere here, right? 5 by 4 is more than 1 but less than 2. 5 by 4, if you do this in a decimal format, you'll find that this is nothing but 1.25. So it is greater than 1 but less than 2. So it will lie somewhere here. So all rational numbers, all irrational number also, root 2 will also lie between somewhere 1 and 2. Root of 3 will also lie between 1 and 2. Root of 5 will lie between 2 and 3. Correct? So whatever numbers we have studied till now, except the imaginary numbers, they are called real numbers. Correct? So whenever such question appear and nothing is said about x, that what kind of this number is, unless it is stated. If nothing is said about it, it is understood that x is a real number. So whatever solution we are finding, it has to be a assumption with it would be under the assumption that x is a real number. When I say x, I'm talking about any variable where it has been taken, unless it is stated. Unless say that x has to be a positive real number, positive integer, negative integer, then that's a different thing. But if nothing is stated, then it is assumed that it has to be a real number, or the variable has to be a real number, right? This is the only thing which you need to understand in the real number, right? Okay, coming back to the inequality. So we know that this is represented graphically in this way. If I want to represent in the bracket format, then this has to be represented how much? Minus 2 till infinity, both open, right? Both open bracket. Had it been like this, then I would have retained the, what do I say? This notation. That in such case, minus 2 would also be a part of solution. So in the second case, it would be minus 2 till infinity. Right? I hope you have understood it. Fine, guys. Now, let's take one more example. So I'm taking one more example which says that 5 minus 2 of x whole divided by 3 is less than or equal to x divided by 6 minus of 5. Okay. It's very much similar to what the previous question is. The only thing is that something is only fraction. We know that how do we get rid of fraction? We have to multiply. Here the fraction is 3, here the fraction is 6. Here the denominator part is 3 and here the denominator part is 6. We have to take the LCM of 3 and 6, which is nothing but 6 itself. What we should do? We should multiply both the side by 6. Step 1 is that you have to multiply both the side by 6. 6 is a positive number. So will there be a change in sign? No. Unless it's a negative, will not change the sign, right? So if I multiply both the side by 6, what we can do is that this 6 will get cancelled out. Or let me write that this would be 5 minus 2 of x whole divided by 3 less than equal to this would be x divided by 6 minus of 5 multiplied by 6. This 6 will get cancelled by 3 2 times. So here I'll be getting 10x minus of 4x. Yeah, what I'm doing. It will be 10 minus of 4x. And here it would be x because this 6 will get cancelled and this will remain 30 if I open the bracket. Now again, let us bring this x on the LHS or bring this minus 4x on the RHS, whatever we wish to do, and this 30 to the LHS. Then what we can do is that to get rid of this minus 4 of x, this would be adding 4 of x both the sides. Correct? Simultaneously, I want to get rid of minus 30. So what I should be doing is that I should be adding plus 30 both the sides. So here we can see that this will get cancelled out. This will get cancelled out. So I'll be getting 40 is less than equal to x plus 4 of x, which is equal to 5 of x. Now let us divide both the side by 5. So I'll be getting 8 less than equal to x. Correct? Or x is greater than equal to 8. One of the same thing. This, the sign will change. Right? On a number line, x greater than something like this. So my 8 would be here. Greater than 8 means what? This value till infinity. Right? It is equal to in the sense x equal to 8 is also a part of solution. So graphically is like the solution is this, and bracket wise we have to write it like this. So this is the answer or the solution. So how many values of x it has? Infinite. Right? So in such cases we don't get finite values of x. Usually we get the range of x, and within the range there are infinite solutions. The only thing what we get is what is the minimum and maximum of x. Fair enough, right? So let's take some examples, word problem to understand how do we frame the equation, and after framing the equation, how do we solve it for the inequalities, right? So let me just take few examples. Let me take both the questions, in fact, or let me take one by one. Okay. So what is the question says? What you can do is that you can pause this video, solve this question, right? Once you have got the answer, then you can continue with the video, right? And please remember that if you are watching this video on a social media platform, then we run online CAT coaching classes for all the 3 sections. You'll be finding the link in the description. You can go to the description, click the link. You'll be finding the number also. You can call to the number if you have any doubt. Once you have gone through the details, if you feel like that there is any doubt or you want to get more clarification on it, please do call on the number given in the description. Okay. Fine. So I hope you have attended this question. So let us solve what this question is talking about. It says that marks obtained by a student of class 11 in first and second terminal exam were 62 and 48. We have to find the minimum marks you should get in the annual exam. So there are 3 terms. One is the first term, second term, and the third term is actually called the annual term. To have an average of at least 60. So here the words have a specific meaning. We know the marks obtained for the first, second. Do we know the marks obtained in the final examination? So this is the unknown. So let us assume it with x. Correct? Now we have to focus on the average. How do we find the average of any number? It's quite simple, right? We add all the number and divide by the number of numbers. If I want to get the average of these 3 numbers, I have to add this and we have to divide it by 3. Right? This would be the average. Now this average has to be at least 60. What do I mean by at least 60? At least 60 in the sense the minimum average has to be 60. The average could be more than 60 also. That is also part of the solution, right? But it should never be less than 60. So mathematically, how do I interpret it? That this average has to be greater than or equal to 60, right? If you haven't understood it, just rewind this video, right, for this particular question and again watch. At least 60 simply means minimum 60, it should never be less than that. More than 60 is allowed. So that means the average has to be either 60 or more than 60. So how do I represent that statement mathematically? By this, the average has to be greater than or equal to 60, right? So this is the way wherein we are interpreting this conditions. Now we have to find the value of x. Nothing very. What we can do is that we can add these two. How much is this? They will become 110 plus of x divided by 3 is greater than or equal to 60. We want to get rid of 3. Let us multiply both the side by 3. 3 is a positive number, so there will be no change in the sign. I'm just taking out 3 from here, and here it will be multiplication of 3, right? Because if I multiply both the side by 3, the 3 in the LHS denominator will get cancelled out. So 110 plus of x is greater than or equal to, this is 180. We want only x. I want to get rid of 110. So what do? We should subtract 110 both the side. On subtraction, there will be no change in the sign. This will get cancelled. So I'll be getting x greater than or equal to 70. Greater than or equal to 70 in the sense, if this is 70, then it should be on this side, right? Equal to 70 is also allowed. So the solution would be what? 70 or anything more than 70 is the solution. But here the question is not saying that how many values x can take. Question saying is that what is the minimum bar? So what is the minimum value which x can take? The minimum value would be x minimum has to be equal to 70 because all other values will be greater than 70. So the answer for this question is 70 because it is talking about the minimum marks he should be getting, right? So with the example, I have also introduced the very fundamental things about finding the minimum and maximum also. Whenever there is a minimum and maximum, that means the things would be in a range. Whenever the things are in the range, that means inequality will take in part, right? This is how the things are connected, right? Let's take some more examples. Now here say that find all pairs of consecutive odd natural numbers, both of which are larger than 10, such that their sum is less than 40, right? You can pause the video on your own, then you can continue with the solution. Okay. So we have to find the pair of consecutive odd natural numbers. That means we have to find the solution in such format, right? If you remember the video of integer, I think I have told you what is pair of integer kind of thing. So pair of any odd natural number. What is odd natural number? Odd is understood natural numbers means what? Positive integers, right? So we have to find how many such pair such that the sum is larger than 10. Sum is larger than 10. Now, just for one clarification, what we can do is that how do we represent two different odd numbers which are consecutive? What is consecutive? Consecutive means one after another numbers, but it has to be odd. For example, 3 and 5, 7, 9, these are consecutive odd numbers, as you can see. If I assume one of the number to be x, the other number has to be x plus 2, yes or no? The other number has to be x plus 2 because the difference between any two consecutive odd number is 2. Correct? So let us assume that the first odd number is x and the other odd number is x plus 2. Their sum has to be both of which are greater than 10. Okay. So both this and this is greater than 10. This is the first condition. And their sum is less than 40. So we have two conditions. If I just consider this, then definitely if x is greater than 10, then x plus 2 will obviously will be greater than 10, right? For example, if x is 12, say 13 in this case. So 13 plus 2, 15 will always be greater than 10. So can I say x greater than 10 itself is sufficient to represent this condition, that both of them are larger than 10, correct? Let us simplify this. So this is 2 of x plus 2 is less than 40. What we can do is that we can bring this 2 here. So we have to subtract 2 from both the sides. So 2 of x is less than 38. We want to get rid of 2 which is multiplied with x. So let us divide both the sides by 2. So x is less than 19. So we have x less than 19 and we have x greater than 12. Let us plot them on a number line. So here it would be 10, here it would be 19 for sure, right? So can I say x greater than 10, that means till infinity, right, from 10, not exactly 10, but any number which is greater than 10 till infinity is the part of the solution. Here less than 19 is this one. So can I say the answer must lie between 10 and 19? It should be greater than 10, but it should be less than 19. So what is the first odd number which comes on our mind when it is greater than 10? 11. So 11 is a part of the solution. Why? Because 11 is less than 19 also. If the value of x is 11, the value of x plus 2 will become what? 15. So this is the consecutive numbers, consecutive odd numbers. So 13, right? I can take the value of x to be 13. Then the next number would be what? 15. I can take the value of x to be 15. Then the next number is 17. If I take 17, then can I take 19? Of course not. Because x has to be less than 90. Correct? So how many pairs are possible? These 3 pairs are possible. So the answer for this question is these pairs. If the question says that how many pairs, then the answer would be 3. Right? So we'll just rest this topic here itself. I have introduced the inequality. I have introduced that how do we do the mathematical, how do we frame the mathematical equation of inequality, and how do we proceed with the solution of inequality. You have to just remember when the inequality sign changes, right? Other than that, it is as good as how do we solve the equality wala questions, right?